Alright, in this video we're going to look at logistic regression. You've done other kinds of regression in the past and you probably never even noticed the existence of logistic regression on your calculator. But now that we know how to develop logistic models, we're going to do logistic regression. We're going to work our way through this example here. The table below shows the population of koi fish in a pond measured over several years. Terrible substitution of a homonym here on my part. I'm calling myself out here. These are koi fish, not koi fish. Anyway, what we want to do first is we want to enter this data into our table on our graphing calculator. And something that I want to do when I do this, and this is a good idea in any logistic model. In the first part of this example, I say use your graphing calculator to find the logistic model for the given data, letting x equals 0 represent 1985. Because in logistic growth models we have an exponent that's going to be potentially sensitive to, that's being multiplied by these time values, it's a good bit of advice to keep those time values as small as we possibly can. So we're going to adjust our years so that this is year 0, which makes 1988 year 3, 1992 year 7, 1997 year 12, and 2000 is year 15. And so those are the data values that we're going to enter into our calculator in order to find our model. So we go to our graphing calculator, and we go into the stat editor, and we're going to go ahead and edit our lists. And we'll type these values in, the numbers for years in the first column. And the numbers for our koi population in the second column. And before I go ahead and run the calculation to find the logistic model, I'm just going to do a little quality control check and make sure that I typed everything into my table correctly. And it looks like I did. So now I'm going to go back out to my main screen, and then I'm going to go to my stat again and go to calc, and you've got to go down a little bit, and eventually you will find, there it is, logistic. And so we're going to choose the logistic regression, and it should use L1 and L2 as the defaults, so I should just be able to hit enter and it'll come up with my model for me. Might take a little bit here. Alright, there we go. And now we have our numbers that we can fit into our logistic model. And we're going to copy those over using the template that's provided for us. Since it says y equals c over the quantity 1 plus a e to the negative bx, we're going to substitute the numbers in accordingly. So y is equal to 196.663 over 1 plus a, and a is going to be 3.298. 1 plus 3.298 e to the negative, and then I need my b. Now, usually with these b values, since they're in the exponent, I tend to keep more than 3 decimal places. I like to use maybe 6 as a kind of standard. So that's going to be 0.123602. 0.1236602 t. And there's my logistic growth model. You know what? I'm going to replace this y here with a p, since this represents the population. And there's my logistic growth model. And now I'm going to use that to answer the questions that I'm given. First, what's the carrying capacity of our model? We're going to say it's 196.663, since that's our m value, which we see right here. And then using our model, how many koi would we expect to be in the pond right now? So this is the year 2018 when I'm making this video. So we're looking at time 33. So we want to put 33 into this model for the time. So we're going to have 196.663 over 1 plus 3.289 e to the negative 0.123602 times 33. And I'm going to go ahead and calculate that using my graphing calculator. And so I've got 196.663 divided by the quantity 1 plus 3.289 times e to the negative 0.123602 times 33, close my exponential, close my denominator, and we get 186.291. And so I'm going to say we expect there to be about 186 koi in our pond right now. Alright, and that's how we perform a logistic regression on our calculator and then use it to answer potential questions about the information. It's the end of this video and this lesson, and we'll see you next time.